So just a quick little note here. I went and ground a flat here. I couldn't, it wasn't working out well when I tried to machine it. I was getting a lot of chatter, so I don't know what kind of hardening or anything's been done to this. But anyway, didn't like machining, so I ground it. What I think, this is the only MT2 dead center I have. What I should have, I think, for this application is something like this, MT3, but in an MT2 version, where it's it has a non-tapered section here, and that's what you would clamp onto. But I think this will work. We'll give it a try. Here's my little thing here. Ah! There we go. Yeah, I think that's going to work just fine. Not sure if that's got glare on it or what, but it's about as good as I can get it. I've been knocking it back and forth for a while now, and I'm calling that good. She's all tightened down. One thing that turned out to be a big pain in the butt was getting my clearance down here for all the little bits and pieces. Honestly, a collet setup would just be so much easier. That's in my future. Now, astute observers are going to say, all right, you have your dividing head here. Where are your dividing plates? This is the only one I have. It's the B plate. It goes from 21 to 33, 21, 23, 27, 29, 31, and 33. I don't have any others. That's a problem I'll have to solve in the future. However, for this particular job, since the gear that I'm making is 36 teeth, I'm in luck, because they do have a 360-degree graduation around this guide here, and it's marked off in 10-degree increments. So that is what I'm going to use. Remember this fellow I made a while back? It says time to shine. Got my proper gear for 36 teeth. This is the number 6 according to this set. I think it's reverse numbered depending on whose set you've got. But the number 6 here goes from 35 to 54 teeth. Mount her up. I said before I should put a key in here. I'm not going to do that. I think this thing will have enough friction. And let's see which direction I want it to go in. I want it to go in this direction here. Yeah, I'm betting, and I could be proven wrong here very shortly, that there is enough strength in this joint as I'm creating it right now, enough clamping pressure when I get me a hex key on there that it will not slip. We'll find out. I'm attempting to use the Bruce Whitman method of center finding here. That's looking good to me. Let's give it a sanity eyeball. And looking good in that aspect as well. Alright, we're getting serious. We're back to our machinery's handbook. We want to know how deep to make the cut for the teeth, which figure in this illustration should be the hole depth. So that goes from the outer diameter to whatever they call the inner diameter. Not quite sure, but that's what we want, is the hole depth. Now the problem is there are several different standards that give you different formulas. So here we have the coarse pitch spur gear, and that's H sub T is 2.250 divided by your diametrical pitch. There's another one here, and this is for fine pitch involute spur and helical gears, and that's 2.2 divided by your pitch plus 0.002. And then there's another one over here, which for our 14.5 degree, which is what we've got involutes, your hole depth is 2.157 divided by your pitch. Now, I calculated them all out, and they come out, your range, depending on whether you're looking at the coarse pitch, it's 0.141, let's say 0.141. If your fine pitch is 0.139, and then your ASA standard is 0.135. I cheated and looked over at Mr. Pete's video, and he actually has some cutters that have his Brown and Sharp gear cutters have stamped on them depth of cut 135. So I'm guessing the ASA standard. Also, this gentleman's website right here, highly recommend if you like Atlas or just machining in general. He's a retired camera repairman, and he still has his website up for his projects, where he's got a Craftsman 618, he's got a TAG, and I forget what else. But just one of these old school guys that just puts me to shame. Just the kind of things he's created. It's amazing, and he instead of buying gear cutters, he basically used a piece of blank high-speed steel and ground out the tooth shape and used that in an arbor to cut his gears. He built his own dividing head, his own rotary table, makes steam engines, just all kinds of cool stuff. That's a really neat site to check out. Anyway, the consensus appears to be 0.135, because this is the formula that he used, and he said he's just been using it for years. This 2.157 is a constant, so that's what I'm going to go with, 0.135. Go. Alright, so I'm going to be here for a while. Taking the lock off, advancing. Should be one tooth. Putting the lock back on. Speed up a bit. Coming down to the last cut. Find out if I have any skinny teeth. Oops. That looks centered to me. I think we're in good shape. Alright, I've been letting it cool down while I did some cleaning around the shop. You can see cutting was from this direction, so I've got a burr on this side. So first thing I'm going to do is I'm going to throw it on the lathe and just clean this edge up a little bit. I've got plenty to play with because all these need to be profiled. But after doing that, I'll bring it back and we'll crack these apart and see what they look like. Alright, exciting moment for me. Let's see. How well did we do? Looking pretty good. Oh, I like those. Alright. And this is what we are replacing. Wow. Let me get some light over here. Pretty amazing, huh? It's a lot of wear. Okay, well, I did goof one thing up. Well, I'm sure I goofed many things up. But one thing that I've noticed that I goofed up is that, remember how I was going to put bushings in these? Well, the correct order of operation would have been to have done that before mounting them on here and getting them all trimmed up together. Because then there would be no doubt that that bushing would be concentric. So I'll do the best I can as far as bushing them out. But I think for giggles, I don't think it'll hurt anything to run it just a little bit on the aluminum. And so that's what I'm going to do, just to see what it's like. Oh yeah, look at that. Looks like this thing could still be, could stand to be replaced. I think it's going to run better anyway. Here goes nothing. Oh wow, that is so much quieter. Oh yeah. That sounds good.